How's it going, everyone? Cup of Science Joe here. Have you ever wondered how we can get magnificent pictures like these? One big answer to this lies in our ability to visit them directly. So, in all of these cases, the orbiter or the spacecraft taking the pictures was actually orbiting the location that it was photographing, rather than, say, Hubble trying to do it all the way from back here on Earth. Yet, even within our solar system, most destinations of interest are quite far away, right? And we're trying to get spacecraft to them. Let's have a few examples. Jupiter is around 444 million miles away from Earth. Its neighboring planet Saturn is around 746 million miles away from Earth. And all the way near the end of the solar system, we have Pluto in the Kuiper Belt. Pluto is around 3.33 billion miles away from Earth. Now that is quite far. We also have limitations. For starters, Earth is trying to pull us back down, right? This thing called gravity. The escape velocity of the planet Earth is 11.2 kilometers per second, or 24,923 miles an hour. This imposes weight limitations on what payloads we can actually lift past Earth's gravity and get into space. Not only that, but payload fairings impose size restrictions as well. If we take JWST, it had to be folded up in order to properly fit in any available launch vehicle. Because we want to send as many science payloads as possible on any given mission, we try to limit how much fuel is placed on a spacecraft. With these limitations, especially including fuel, how can we travel so far? Now, one thing to keep in mind is that the speed the launch vehicle itself gains is imparted into the spacecraft, right? So it has an initial burst of speed, but oftentimes that's just not enough to get us to our destinations. And this is where the gravity assist comes in. We can think of a gravity assist as a cosmic slingshot. By passing by and around, say, a planet or whatever object has enough gravity to propel us, and by timing our trajectory and the way we come at the planet properly, we can use that planet's gravity and its rotation to push our spacecraft into the intended direction with greater speed than we started. I like to visualize this as, say, we're all on a carousel, going in a circle, and there's a wall behind us keeping us from flying off at a tangent off said carousel. So essentially, a gravity assist is us allowing this, or us planting the spacecraft into the carousel of a body like a planet. So basically, we're caught up in its rotation and also in its gravity, but reserving just enough fuel or using just enough fuel to effectively remove that wall when we're ready to shoot off in the chosen direction. And so we get kind of a slingshot effect here, where the spacecraft is launched off and it has propelled itself just enough to break free of the planet's gravity at the same time. This allows us to travel much greater distances while minimizing the amount of fuel that we used to do so. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.